So, what's the deal with quantum? So, there's a ton of hype around quantum computing, you know. You see these headlines about teleportation, unbreakable codes, computers that can solve any problem instantly. It all sounds like something straight out of a blockbuster sci-fi movie. But if you strip away all that noise, what are these companies, the ones with the giant chandelier-looking machines, actually doing day to day? What's the reality behind the press releases and the billion-dollar valuations? Myth versus reality. Here's what quantum companies actually do today. Not sci-fi, not future promises. Myth: you buy a quantum computer. Reality: you rent one. You can't just buy one like a server rack or workstation. The myth: you own and install these products. The reality: almost no one is selling the physical hardware. It's not practical. They are incredibly sensitive. Massive, specialized cooling systems. They need constant maintenance and calibration by PhD physicists. They're closer to a particle accelerator than a desktop PC. So what are they selling? Access. Think of it like cloud computing in its infancy. IBM, Google, Quantinuum, Rigetti. You, as a customer, a researcher at a university. You, as a customer, or a big corporation's R&D department. You log into a platform from your regular laptop. You use their SDK Jandans Sam SDK Instans developer tools. You send the job to the cloud queue to wait its turn. You're renting time on a multi-million-dollar experimental machine. Pricing: paying per quantum circuit execution. Pricing: buying a block of reserved time, like early mainframes. A single machine filled a room. Organizations book time to run calculations. It's a shared resource model, not consumer ownership. And for the foreseeable future, that's how it's going to stay. Think of this as a behind-the-scenes tour of an industry that's still in its very early days, kind of like the dawn of classical computing, but with way more physics involved. Myth: they're solving grand problems. Reality: they're fighting noise. You hear about quantum computers factoring huge numbers or designing miracle drugs. The myth is that the daily work is this high-level, revolutionary problem-solving. The reality: probably 70%, maybe even 80% of the engineering effort inside these companies is a brutal ground-level war against noise and errors. A quantum bit, or a qubit, is an incredibly fragile thing. The slightest vibration, a tiny change in temperature, or a stray electromagnetic field can knock it out of its delicate quantum state and destroy your calculation. This is what physicists call decoherence. This means the primary job for most quantum hardware engineers isn't running fancy algorithms, it's noise reduction.